Alright, so today we'll look at integration by substitution, where in this chapter you really have to choose wisely which one is going to be substituted. So like in the first example here, we have this integration of 3 minus cos cube x of sine x dx. So you have to find something that you have to let u, like for example in this case, maybe you can try like for example you try let u equal to sine x. And then you have to differentiate u and it'll become du over dx. You get cos x, and then what you get is something like you have to make dx as a subject, so dx will be equal to du over cos x. You'll have something like this, and then you try to substitute back into your integration, so you'll have something like 3 minus cos, we didn't disturb anything there, so we'll have something like sine x is changed into u, and then dx is you will have du over cos x. So our intention is to cancel actually cos x here and this cos x. However, when you try to cancel this, you will fail to cancel because this is cos to the power of 3, but this is cos to the power of 1. So meaning that your let u just now is wrong. So try to have another u. So in this case, actually you have to take u as cos x. Do not take cos to the power of 3x because when you try to differentiate cos to the power of 3, it'll be very complicated. So you'll have in this case du over dx is actually negative sine x. So make dx as a subject always. So we'll get something like du over negative sine x. And then we'll try to substitute in the equation. So you'll have something like 3 minus u is cos x, so u to the power of 3 here, right? So sine x is there, we didn't disturb anything, and dx is actually du over negative sine x. And then we'll see that we can cancel sine x with sine x here. So you will have something like, alright, 3 minus u to the power of 3 of negative du. And then we'll try to distribute the negative, so you'll get something like negative 3 plus u to the power of 3 du. So you try to integrate this, and then for a number you get negative 3u. Now it is in terms of u, everything must be in u. So plus u to the power of 4 over 4. Remember the integration, we have to add 1 to the power and divide with the new power. Because it is indefinite integral, so you have to plus c. Alright, so we're done with the first one. However, because it is in u, you have to get back in terms of x. So we know that u is just now that u equal to cos x. So you have to rewrite that u in terms of x. So 3u is actually cos x. So 3 cos x plus cos to the power of 4 of x over 4 plus c. So we are done with the first example. Let's move on to the second example here. So in this example, again, we have to try to find which one is going to be substituted. So in this case, actually, we try to put, if you put like, let's say you let u is equal to 4x, and then you will have du over dx is equal to 4. But this is useless because you cannot cancel that ln x there. So meaning that your choice was wrong. So in this case, maybe you can try 3 plus ln x to the power of 3, alright? 3 plus ln x to the power of 3. But bear in mind, when you try to differentiate this, you get very complicated. So, like for example, in this case, you'll have 3 cos plus ln x to the power of 2, and then you have to differentiate the one in the bracket, you get 1 over s. Very complicated because, you know, you cannot cancel anything here. So actually, you will have to take the one only in the bracket, so meaning that without the power. So we'll have to take this as u. So 3 plus ln x. Because when you try to differentiate this, you get 1 over x. So now, make dx as the subject. So dx is equal to x du. Alright. So try to substitute back in the initial integration. Alright. So this one is going to be u. So the one is u to the power of 3. Alright. That's it. U to the power of 3 plus 12 over 4x dx is actually x du. And now we can see that we can cancel x and x here. So you will have something like u to the power of 3 plus 12 over 4 du. All right. In this case, you try to simplify first, meaning that you have to separate it, all right? So u to the power of 3 over 4 plus 12 over 4 is actually 3 du. All right, so everything is in u now, no x anymore, so you can integrate it. So you'll have u to the power of 4 over 4, the initial one, and the new power is 4, plus 3u plus c. So substitute back, u is actually this one, 3 plus ln x. So you'll have something like 3 plus ln x to the power of 4, all right, over 16 plus 3 plus ln x plus c. We are done with that one. Okay, let's see this one. So we have to find something that you have to let you actually again and again choose wisely. It's like you're going to choose your girlfriend, you're going to choose your wife. You have to choose really wisely. All right, so in this case you have to let you. All right, let's say if you choose sine 3x. Let's try first, huh? All right, so du over dx is actually given by 3 cos 3x. And then, if you get, you have to make dx as the subject, and then you will have something like du over 3 cos 3x. All right. So now, we try to substitute in the equation. So you'll get something like e to the power of 2 cos 3x. Sin x is given by u. Dx is du over 3 cos 3x. You try to cancel the cos 3x here and here. However, it fails because this is the power of u, but this is the one at the denominator. So what you have to do is that, in this case, your choice was wrong of choosing u. So actually, when you choose u, it shouldn't be this. In this case, it shouldn't be sine 3x, but in fact, it is actually cos 3x. Or maybe you can choose 2 cos 3x. All right. So let's try 2 cos 3x. Why? Because when we differentiate this, you got negative 6 sine 3x. And then you'll have something like dx is given by du over negative 6 sine 3x. Okay, so we'll try to substitute in the initial integration. So e to the power of this one is going to be u already here. So e to the power of u is something like u. Alright, so now sine 3x is there. You just write it back because we didn't do anything to that. So dx is actually this one. Right, so du over negative 6 sine 3x. Can't you see something that can be cancelled here? Of course, sine 3x with sine 3x. And you can take negative 6 here. You can bring out there. So, because it is at the denominator, so keep it as the denominator. So, negative 1 over 6 integrate of eu du. So, you know that when you try to integrate eu, so you'll get something like, alright, you try to integrate this, you still get eu. So, negative 1 over 6 eu plus c. And then try to write back u as the 2 cos 3x here. So now you'll have something like negative 1 over 6 e to the power of 2 cos 3x plus c. So we are done with this example. Alright, let's move on to the fourth example. Alright, to the fourth example here, we have this. So again, we have to choose wisely which one is going to be substituted as u. So I'm gonna let you. In this case, actually, we have to choose. Alright, let's say some of you might be confusing. Sometimes we have to choose which one, 2 plus cos 4x or cos 4x only or sin 4x. So actually, we have to use the one as in the denominator. But which one? The whole thing in the bracket. Is it 2 plus cos 4x? Or is it cos 4x only? Is it cos 4x only? Or is it the whole thing in the bracket? Alright, if you choose this one, then you try to differentiate and it will be very complicated because this will use the bracket technique. Alright, so now actually the one that you're going to choose is actually, let's try, we choose cos 4x only. Alright, so let's try to choose cos 4x. Alright, so you will have something like du over dx, you'll get something like negative 4 sine 4x. And then you'll have dx as a subject, so du over negative 4 sine 4x. Okay, we try to substitute back. So you'll have something like sine 4x, okay, over 2 plus u square of this du over negative 4 sine 4x. Yes, very true that negative 4 sine 4x can be cancelled sine 4x and sine 4x here. However, you have this 2 plus u square. You have to, like expand this square, and then it'll be very complicated because you'll have something like you have to integrate 4 plus 4u plus u square, and we never have this kind of technique in the integration. So meaning that our choice was wrong. But what we're going to do is actually I'm going to write back, alright, that our choice of choosing this is actually we have to take 2 plus cos 4x, and then we try to, when you differentiate this, 2 will be 0, so will disappear easily there, and then still you get the same differentiation. Alright, so but when you try to substitute it back in here, it will be a bit different. So as like you choose u the whole thing at the bottom, alright, so u square, and dx is actually du over negative 4 sine 4x. Very different from the previous one. So now we can cancel sine 4x and sine 4x here, and then you'll have something like like du over negative 4 u square. Actually that negative 4 can be taken out of the integration, so it'll be something like negative 1 over 4. Don't put negative 4 at the numerator because it is as the denominator. Don't change them. Alright, so you'll have something like du over u square. Or maybe you can't see this as integration, so you have to modify a little bit. So it will become u negative 2 du. You try to use the technique of integration, like when you integrate this, you have to add 1 to the power. So you'll get something like negative 1 over 4, and negative 1 over 4 u to the power negative 1 over negative 1 plus c. This is actually, you get positive, so you get something like 1 over 4u plus c. What is u? Try to substitute back u as 2 plus cos 4x, so you'll get something like 1 over 4, 2 plus cos 4x, and then you have the plus c. Why you have the plus c? Because it is indefinite integration. Alright, let's get to the next one. You will have like ln y square over 3y, so you have to be very careful in choosing which one is going to be substituted. Alright, so in this case actually you'll have to let u, if you choose ln y square, it will be quite difficult. Alright, let's try choose ln y square, so du over dy in this case, so you'll get something like 1 over y square, and then differentiate y square, you get 2y, so you'll simplify this, you get 2 over y. Alright, so please make dy as the subject, because in this case we use y as the variable. So now dy of the subject, so we'll get y over 2 du. Alright, y over 2 du. Okay, so now we try to substitute in the initial integration. You'll get something like u over 3y. dy is actually here y over 2 du. Alright, we'll see. Alright, we can cancel y and y, so of course you'll get something like u over 6 du. Alright, so our choice was correct, so I thought it was wrong. So like in mathematics, sometimes you have to try and error, try and try again until you get the answer. As long as you get the answer, you can try and try. If you don't get the answer, don't keep trying. I mean, you try to change to something, some alternative. So in this case, it will vary 1 over 6, and then you'll get u squared over 2 plus c. So you try to simplify this, you get something like 1 over 12 u squared plus c. U is given by ln y square, so it will become 1 over 12 ln y square plus c. And please bear in mind, don't multiply this square to this square on y, so become ln y to the power 4. No, don't do that. Just keep your answer as this and don't proceed to anywhere else. Alright, so let's move on to the next one. You have to find something that's going to be let u. Actually, you can see clearly if you try a lot of questions, you can see obviously in this case we have to choose u as tangent for x. Why? Because you have tangent for x. When you differentiate tangent, you get secant square of 4x. When you have secant square, and then you can cancel that secant square with this secant square. Alright, so in this case, actually, let u tangent 4x. Do not choose tangent to the power of 3 because it will be very difficult. When you try to differentiate tangent to the power of 3, it will be very complicated. So now you will have something like But if you choose, like tangent 4x, so you got something like 4 tangent is secant square 4x. Alright, this is actually the nice choice. So you'll have something like u to the power of 3, because we only let u tangent 4x, but we have to the power of 3 here, that's why u to the power of 3 is here. Okay, so now we'll have something like, like secant square 4x. We didn't disturb anything there, secant square 4x, but dx will become, sorry, I didn't let dx as the subject, so dx is actually du over 4 secant square 4x. So du is given by dx is given by du over 4 secant square of 4x. So can't you see that secant square 4x and secant square 4x here can be cancelled out simply like this? So, when you try to proceed to the next one, so you will get something like 1 over 4 u to the power of 3 du. Alright, then you can simply integrate this. So become 1 over 4 u to the power of 4 over 4 plus c. So u to the power of 4 over 16 plus c. So you'll have u to the power of 4 over 16 plus c. So let's get back what was the one that you let u. So in this case, tangent 4x. So of course, you'll have 1 over 16 of u is tangent to the power of 4 of 4x plus c. And then you're done. Alright, so let's proceed to the next example. Alright. Okay, in this case, you're sometimes confused. You get confused. Which one is going to be let as u? So in this case, if you try to let u, maybe you can try cos theta. Of course, du over d theta, you get negative sine theta. But are you going to be able to substitute that one? I mean cancel sine theta. So you'll have something like cos theta. Cos theta is let as u already. So sine squared theta. And then you'll have, like du, d theta is du over negative sine theta. You cannot cancel this sine theta with sine theta here. So what does that mean? Meaning that your choice was wrong. So in this case, actually, you'll have to choose u as sine theta. Why not sine square? Because when you try to differentiate sine square, it is very, very complicated. So you have to choose sine theta. So you choose sine theta, you differentiate that one, you get the cos theta. And then you have to let d theta as the subject. So it will become du over cos theta. Okay. So we try to substitute. So you'll have cos theta over u is going to be let as sine theta, so u square, and d theta is actually du over cos theta. And we can easily see that this cos theta and cos theta can be cancelled out. So now you'll have integrate 1 over u squared du. Some of you get confused. When you see this, you try to jump to the conclusion that it will become ln u square. No, it's wrong. You have to change this into something like u to the power negative 2 du. Alright? So only then you become, so u squared d, u to the power negative 2 du. So you have to add 1 to the power, so it'll become u negative 1. So divide with the new power, negative 1 plus c. So this is actually negative 1 over u plus c. But what is u? U was sine theta, so we have to write negative 1 over sine theta plus c. Alright, nice, that one is done. Okay, so let's see this example. You have to choose wisely which one is going to be let u. So actually you have to let u in this case. Let u is equal to, it is very clear because you have to choose this one into the bracket. Why? Because when you differentiate that one, you get 4x above 3. X above 3 can be cancelled with this x to the power of 3. So you have to let u equal to x to the power of 4. So now du over dx will become 4x to the power of 3. And then we have the dx as the subject. So du over 4x to the power of 3. So now you will have something like x to the power of 3 secant square. The one in the bracket is become u already. So dx is actually du over 4x to the power of 3 as written by this one. So now we can cancel actually x to the power of 3 with x to the power of 3 here. So leaving only, you take out 1 over 4 outside the integration. So you'll have secant square u du. Do you know how to integrate secant square? Of course, we get back to the tangent. Alright, so negative 1 over 4 tangent u plus c. What is u? U is actually this one, 1 plus x to the power of 4. So you will have something like 1 over 4 tangent 1 plus x to the power of 4 plus c. You're done with this one, alright? So let's see the next example. I'm not going to see this one because I think I have discussed this kind of example. So let's move on to the next one. I think this one also almost the same because we try to differentiate tangent. 2x plus 3 becomes secant square and we can cancel secant square. Alright, this one is quite interesting. It is easy actually. We have to use let u is the one in the bracket again for x to the power of 3. Why? Because you try to differentiate this one, so we'll get 12x squared. This x squared and x squared can be cancelled later. Alright? Maybe you can't see now, but later you can see 12x squared. Alright, so you will have something like x squared sine u dx is actually, alright, I'm sorry to make dx as a subject, so du over 12x squared. This one is going to be written here, so du over 12x squared. And then you can see that this x squared and x squared can be cancelled out easily. So you'll have something like 1 over 12 integrate of sine u du. Integrate sine u, you will become negative cos u. Be careful, don't misunderstand the concept of integration and also differentiation. Alright, so this one will get something like negative 1 over 12 cos u. What is u? U was let as 4x cubed, so you have cos 4x cubed plus c. We are done with this example. And you know, like if you have this one, alright, tangent to theta, last one maybe. So actually you have to, you know, like modify the initial integration. Alright, so it will become tangent is actually given by sine 2 theta over cos 2 theta d theta. So you have to let u. Which one is going to be let u? So actually in this case we have to let u, I think cos theta. Alright, why? Because when you have this one, so it will become du over d theta negative sine theta and make d theta as a subject, so du over negative sine theta. Okay, so now you will have something like, sorry, can I use in the pen and the red pen? Alright, so will become sine 2 theta is there. I'm sorry, you have 2 theta here, so will become 2 here, negative 2. Alright, sine 2 theta over cos 2 theta is was let as u. D theta is du over negative 2, sorry, sine 2 theta. And we can see that this sine, this sine 2 theta and sine 2 theta can be cancelled out. So leaving only, you know, like negative 1 over 2 outside, and then we have 1 over u du. This one only you can use as ln in the integration. So negative 1 over 2 ln u plus c. What is u? U is actually cos 2 theta. So you will have negative 1 over 2 ln cos 2 theta plus c. That